All right, welcome back to another episode of School. I'm your math teacher, or maybe I'm not, that's fine too. Today we are going to be talking about completing the square. So this is day 5 in our note packet. So if you have your note packet, you should have that out. We're starting off here at page 21. And if you don't have your note packet, I know I have posted the entire note packet on Schoology. I would suggest maybe just printing out the pages you need, like maybe day 5 for today, or whatever you need for that. So let's jump right into it. Day 5, we're going to complete the square. So we talked about the quadratic formula and how that's used to solve any quadratic equation. Here's another method that can be used, and it's a pretty good method. Some people like it a lot. Some people don't really like it. That's fine. So we have these methods that we've talked about so far, right? So we have a graphical method to solve. We're talking about solving quadratics here. So how would we use a graph to solve a quadratic? Well, we would kind of put that into y equals on the calculator, right? So I'm kind of talking about the calculator here. And we would calculate the zeros, because the zeros are the solutions to the quadratic equations, or the x-intercepts. So remember, we can calculate on the calculator, which we will probably show you there. We can calculate the zeros. So remember, and I will bring up the calculator just real quick. What I'm talking about here is the calculate feature, which is second trace. So if I press second and then trace, you can see there the option 2 is to calculate zeros. So that's one way we can use the graph to solve these quadratic equations. When to use, we can only use this method when it doesn't say algebraically. Okay. Oh boy, that's pretty bad. Well, that's supposed to say algebraically. I'll get better with this writing. I'm sure I will. Factor. How do we factor? Well, that was a huge part of like Unit 4, right? So that's Unit 4. Factor. So we set each factor equal to 0. Set each factor equal to 0. And we solve from there. When to use this? We could use this really anytime it's factorable, right? So how about if it's factorable? Okay, getting a little bit more legible maybe. Quadratic formula, how do we use that? Well, it's kind of what we reviewed last time, and we just sort of identify A, B, and C. And we plug in. To the formula. When do we use this? Again, we can use this pretty much anytime we want, especially if it says algebraically. So both of these here are algebraically. I'm going to try and write that word again here. Algebraically. And I've run out of room, and I'm going down the page. All right. Let's move on here and do something real quick. Okay, good. So now we're going to talk about completing the square. So those were we just went over the methods we have before. Now we're going to talk about a new method called completing the square. So first thing is let's take a look at this quadratic x squared plus 4x plus 3. We're going to use our graphing calculator to find the following things. So let's plug this into our calculator. So I'm going to go to y equals, and I'm going to type in x squared plus 4x plus 3. And I'm going to kind of look at this graph, and I want to make sure I can see all the real main features of it. I'm just going to start with my standard window, so I'm going to zoom 6. Okay, so can I see the turning point? Yes, I can. Can I see the x-intercepts? Yes. Can I see the y-intercept? Yes. So I can see everything on the graph, so it's a good window. So to find the x-intercepts, I told you that one way is we could second trace, so calculate the zeros, right? So option 2. And now it's going to ask me to be on the left side of the 0. So remember, these are x-intercepts. So I know where the x-intercepts are. So if I want to find this first one here, or the one I'm closest to, I want to be to the left of it. I want to make sure I'm on the left side of it. And I hit enter. Now it says right bound. So now I'm going to move to the right. And I want to make sure I'm to the right of that x-intercept and hit enter. It'll ask me to guess. I don't have to do that. I can just hit enter one more time. And it gives me the 0. So the first 0 here is x equals -1. That's when the function equals 0. So one of my x-intercepts is x equals -1. So let me take that off. So x equals -1. Now there's another one, and I'll show you another method we can do. We can go to the table. So I'll hit second graph, and I'll look at the table, and I'm looking for which x values make my y value 0. So I'm looking at the y column. There's 2 zeros. One of them is -3, one of them is -1, which we already found. So the other x-intercept, x equals -3. We can write these as coordinate pairs as well. And there we go. The y-intercept is when x is 0. So if I look back at this table, when x is 0, y is 3. So our y-intercept is y equals 3, or 0, 3. All right, the vertex, the maximum or the minimum. For this, I'm going to again review how to find that on the calculator using the calculate feature. So I'm going to press calculate, which is second trace. And I remember what the curve looked like. It was opening up, so I know it's a minimum. So I'm going to calculate the minimum. So I'm going to choose option 3. And again, it's left bound, then right bound. So I want to be to the left of the minimum. So now I know I'm definitely to the left of where the bottom of the graph is. I hit enter. Now I move to the right and hit enter. I don't have to guess. And there's my minimum, -2, -1. So it's -2, -1, and that is a minimum. Does the quadratic open upward or downward? It opens upward. All right, it's a U shape, it's not an upside down U. All right, so we found some features of the quadratic, and we used standard form. Number 2, can the function be written as y equals x plus 2 squared minus 1? Okay, maybe. Let's find out. So what we're going to do is we're going to take this and we're going to expand it to see if it matches the original function. So x plus 2 squared means x plus 2 times x plus 2. And then there's still minus 1 out there. So now what I'll do is I'll double distribute this. So x times x squared, and then x times 2 plus 2x. Now 2 times x and 2 times 2. And I still got a minus 1. Now when I go to combine like terms, and this is my function I'm talking about, when I go to combine like terms, I get y equals x squared plus 4x plus 3. And we can see that these two things match. So yes, they are indeed the exact same equation. So question 3, what aspects of a graph are easier to find if the quadratic is written in this standard form? So what do you guys think? What do we see easier from this form? So if I'm looking up at question 1, what of these things that I found in question 1 can I easily identify from the standard form? That's going to be the y-intercept, right? Because right here, this 3 is showing us it's the y-intercept, right? So we can see the y-intercept because it is the c value, right? Or the constant term, that term with no variable. So what aspects of a graph are easier to find if the quadratic is written in this new form? Y equals a times x minus h squared plus k. All right, well, let's compare these. So if I'm looking at this form, let me change this. Okay, so if I'm looking at this, right, what can I see from question 1? Well, if you notice, I got a minus 1 here and a 2 here. So I'm thinking maybe it has something to do with that right there. And in fact, it does. So let's go back. What aspects are easier to see? It's the vertex. And in fact, this is called vertex form. So it didn't quite give us exactly the vertex. If you notice, there was something a little bit different. So let's take a look at these examples. What I want you to do is I want you to plug these into your calculator and calculate the vertex using that calculate feature. The second trace, find the minimum or the maximum, depending on which way the graph opens. So I will go ahead and do that now. And don't forget, as we go through these notes, if we get to practice problems and things like that, what you should be doing is you should probably be pausing, trying to do it on your own first, and then resuming the video, making sure you agree with what I've done. All right, so let's start with this first one, part A, x minus 3 squared plus 2. And can I see it? Yes, I can. So we're going to calculate the minimum. Got to find my cursor. There it is. I'm on the left. I'm on the right. And its minimum is 3, 2. Now, this is something interesting that the calculator will do. The calculator actually creates, when it's finding these minimums and maximums, it creates a rounding error. It's an actual error on the calculator's part. That is not the actual number. It's not 3.000006. It's 3. So the actual value is 3, 2. Right, so the vertex here is 3, 2. Okay, so we can kind of see what's going on here maybe. Next one, let's take a look at that. Negative x plus 1 squared, and we're going to minus 5. Can I see the vertex? Yes, I can. Calculate. This one is going to be a maximum because of the way the graph opens. So I have to remember I have to choose the correct one, min or max. So I'm going to check max, go to the left, go to the right, missed, go to the right, enter. -1, -5. Again, that's a little rounding error there. So we got -1, -5. Okay. We're looking for a pattern of how to relate this form to the vertex. Last example. Going to plug this in. Okay, you can see the vertex. It is a minimum. Let's go to the left. Let's go to the right. Okay, now here's another rounding mistake again. -4.999999. That's 5, -5. So -5, -8. Is the vertex. So, where do we see these values? Where do we see these vertex values, the coordinate points, in this form? I kind of started underlining these, right? So it looks like this y coordinate, 2 and 2, -5, -5, -8, -8. The y coordinate's pretty straightforward. It's that last value out there. The x coordinate, 3, -3, -1, +1, -5, +5. So the x value has a different sign on it. And if we think back to transformations, remember that whenever we did adding or subtracting things inside the parentheses, to talk about like which way it moves, remember we used to say you gotta have to think opposite. So with this vertex, the number inside the parentheses, think opposite sign, okay? So in this form, we have this form, which I tried to just rewrite this. And if you notice, it says -h. So this h, the minus would sort of change the sign on it. So the h is the x coordinate, and the k is the y coordinate. That's our vertex. Okay, so this is called vertex form. How are we going to put these functions from standard form into vertex form? That we're going to be doing by completing the square. And this is what I mean by completing the square. So remember double distribute, right? If I were to take x plus 7 and square that whole thing, it means x plus 7 times x plus 7. So let's see what we get here. When I double distribute this, I'm going to get x squared, right? X times x, and then x times 7, and then 7 times x, and 7 times 7. And when I combine like terms, I get x squared plus 14x plus 49. Okay. How do the numbers that we ended up with, how do these numbers compare to the number 7? What do you think? Does 14 and 49 have any relation to the number 7? The answer is yes. 14 is 7 plus 7, right? And 49, oops, is 7 times 7. So that's how they relate. What you could do is you could use this idea to then kind of get a shortcut to rewrite something that looks like this into something that looks like that. So let's try that right now with these problems, right? So part A, x squared plus 6x plus 9. I want to write that as a binomial squared. Well, so, okay, what number doubled gives us 6 and squared gives us 9? So this is another way to think about this. This is doubled, right? 7 doubled, and this is 7 squared. So what number doubled is 6 and squared is 9? It's 3. So we're going to have x plus 3 squared. Okay? So go ahead and finish these examples, and then I'll go ahead and finish them as well. So x squared minus 22x plus 121. What number doubled gives me negative 22? And when squared will give me positive 121? It's going to be negative 11. So x minus 11 squared. Okay? Part C, 10 and 25. So that's 5. Part D, 30 and 225. Well, that's going to be 15. Part E, negative 2 and 1. What doubled is negative 2? Well, x minus 1. Just negative 1. And if you square negative 1, you get positive 1, right? Negative 1 times negative 1, positive 1. Part F, x squared minus 18, x plus 81. It's going to be x minus 9 squared. Okay, so this is the idea we're going to use when completing the square. What I want you to notice is sort of how I came up with these numbers. And the easiest way to come up with those numbers is just to take this b value and divide it by 2, right? 6 divided by 2 is 3. The negative 22 divided by 2, negative 11. And so that's going to be part of the shortcut I'll go over. But it's part of one of the things we have to just kind of remember when completing the square. It's kind of like a formula. So let's take a look at these. This is all worked out for you. This is an example of completing the square. So we're going to take this equation and we're going to complete the square with it. So we're going to write it in vertex form. So what's going to happen is we're going to kind of ignore the c value for now. We're going to just focus on these first two terms. And so what we want to do is we want to take a look at the b value, and we take half of it, right? Like what we did up here, right? We took half of the b value, and then we're going to square it. We're going to do that so that we can create something that looks exactly like this, right? Because I probably should have mentioned this before. If we're starting with this, I can't just do what I did up there, right? Because half of 8 is 4, but 4 times 4 is 16. It's not negative 10, right? So this doesn't work. So this is what we're going to do. We're going to kind of figure out what that number is. 16. And because we can't change the value of the equation, we're going to add 16, and we're also going to subtract 16. Because if we add 16 and subtract 16, we haven't changed the value of this equation at all yet. The reason why we do that is because now these three things here, now it looks like one of these things up here in these examples, right? So now half of 8 is 4, and 4 squared is 16, so I can rewrite this as x plus 4 squared, or x plus 4 times x plus 4. And then over here, I just combine like terms with these, right? So negative 10 minus 16, negative 26. And I end up with vertex form. So that's sort of a written out example. Let's take a look at one as we do together, okay? So number 1, rewrite the following quadratic functions into equivalent vertex form and identify its vertex. So I will show you the example of how we did it up there. And if you want to try this first, please do so, see if you can follow that example, and then resume the video whenever you're ready, okay? So here what we're going to do is we're going to take this and let me get rid of that. And I'm going to first start by sort of separating this. I know the example used parentheses. I'll use parentheses eventually, but I just want some space to write in that number. Over on the side work here, what's 12 divided by 2? That's 6. And what's 6 squared? Well, that's 36. So I know that 36 is the number I'm going to add and subtract to this equation. So x squared plus 12x, and here's where I'm going to add my 36. Always added first. And then I'm going to subtract 36. Okay? Now here's where I kind of group these, right? These first three can be factored. And you can think of it in terms of sum product, what two numbers multiplied will give us 36 and added will give us 12. That would be 6 and 6, so x plus 6 times x plus 6. Combine the like terms over here. And what's x plus 6 times itself? X plus 6 squared. And so there's our vertex form, okay? And so what are the coordinates of this vertex? Remember, the inside coordinate changes sign. So negative 6, negative 4. Okay? So there's completing the square. That's the whole thing to it, right? I like to do this side work here. It helps me know which numbers to write down. I'm going to just kind of point this out here. You can see here, oops, this number gives us this, okay? And this number is what we're subtracting on the outside, adding on the inside, okay? So I just wanted to point that out because there is kind of a shortcut method. It's how I do these. And again, if this worked fine for you and you understand this, then please keep going with that. I do just want to show you what I do for a shortcut. So I'm going to do that in number 2. So let's take a look at number 2 here. My shortcut method is I jump right to my side work and I just take b and I divide it by 2. Right? So what's negative 4 divided by 2? And I'm going to write that in parentheses. Minus 2 squared. I'm going to jump right to that point. Okay? So I just take half of it and I go to this. But now I have to remember to subtract something off of the end, right? If I'm looking back up here in red, I have to subtract this value. So now I'm going to do this squared. What's negative 2 times negative 2? Well, it's 4. So I have to subtract a 4. So I subtract 4 off of the C value, and now I have vertex form. So I probably have to show some work here, right? I probably have to show that I did -4 divided by 2 and got -2. But this is completing the square. It's kind of throwing a lot of steps in together, but I kind of feel like procedurally it's pretty simple, right? Just take half of it and rewrite it as a binomial squared, and then take that squared number, right, and subtract it off the C value. Okay? And then the vertex here is +2, -9, because the sign changes inside. Okay, next example, 3. Let's go ahead and try any method you want there. I'll show you the full worked out method. Y equals x squared minus 2x, and then my side work here, half of -2 is -1, and -1 squared is +1, so I'm going to add the 1 here, and I'm going to subtract the 1 from the C value. So this is now factorable to x minus 1 times x minus 1, or if you want to just jump to x minus 1 squared. These combine into -16. So we get x minus 1 squared minus 16. And so our vertex is 1, -16. All right, it's completing the square. So what we can do with this, and before we do that, let's talk about what happens if the A value is not 1. So there's one extra step to this. If there's a leading coefficient other than 1, the first thing we have to do is we have to divide the whole equation by whatever that value is. So in this case, it's 2. So we're going to divide everything by 2. And so I have y divided by 2 equals x squared plus 4x plus 6. Okay? Now from here I'm going to do the completing the square. So I still have y over 2 equals, and I'm going to just complete the square here. So b value is 4. So that's x plus 2 squared. 2 squared is 4, so let's subtract 4 off of this. That would give me +2. Okay, completed the square. The last step now is I have to multiply this value back into the equation. So I have to take this 2 and multiply it back to the other side again now. So y equals, so multiply by 2, so 2 is the coefficient now, and multiply that 2 to the other term out here. And so we get 2 times x plus 2 squared plus 4. Our vertex in this case is -2, 4. Okay? Now the last thing we're going to talk about is we can use this method to solve quadratic equations. So the reason why I like to do this sometimes is because if it's written in vertex form, there is, so take a look at this. This is in vertex form, right? This is what we're trying to solve. The great thing about vertex form is that there's only one variable. There's only one x in this equation. If there's only one x in the equation, then we just have to do our regular solving techniques to isolate that variable, to get that x by itself, right? So if there's only one x in an equation, just work all those inverse operations and get that x by itself, right? So you see here what they did was added 45 to both sides, right? To get rid of a minus 45, add 45. To get rid of a squared, take the square root. To get rid of a 3, subtract 3. And then they come up, and then they simplify the square root sign. So here's an important thing to remember. Whenever you take a square root, you have to write in the plus minus sign, because remember what you're doing here. If I just show you an example, like what we're doing is we're thinking about something like this. X squared equals, let's say 25. Right? What values of x can I plug in to this equation so that it's true? If you said 5, that's correct, but it's not all of the values, right? Because I can plug in 5 and negative 5, because negative 5 times negative 5 is positive 25. And so that's why we use this plus minus sign, so that when I'm solving something like this, and I myself write the square root sign in, the square root and squared cancel, and the square root of 25 is both positive and negative 5. Okay? We have to do that because that's the way we'll get two solutions in this quadratic. Okay, so next page, what we're going to do is we're going to complete the square on all of these examples, and then we're going to use that completed square form to solve for x. So right now in standard form, right, there's two different terms with the variable in it. There's an x squared, there's an x. So that's why we complete the square, we get down to one single variable, and then we can just get it by itself. So let's complete this square. 10 over 2. 10 divided by 2 is 5, and 5 squared is 25. Okay, so that's the side work I'm going to need, right? So x squared plus 10x plus 25. And then I have the plus 21, and I subtract 25. Right? I've added 25, I've subtracted 25. And this still all equals 0. Okay, now these first three can be factored into x plus 5 times x plus 5. And then these can be combined. I got a minus 4. Now I rewrite this in vertex form. And now we're done completing the square. Now we're going to solve this. So how do I get rid of a minus 4? Add 4 to both sides. So I got x plus 5 squared equals 4. How do I get rid of the squared? Take the square root. So we're going to take this square root, and what do we have to remember to write in? We have to remember to write in the plus minus sign. So we get x plus 5 equals, it's the square root of 4. If you said 2, you have half of the answers correct. Positive and negative 2. Now we subtract 5. And this is what we get. We get x equals negative 5 plus and minus 2. Of course, we can go ahead and give our two answers. So what is negative 5 plus 2? That would be negative 3. What is negative 5 minus 2? That would be negative 7. And there we go. We're done. We've solved that equation. Okay? So for the next two, I will go ahead and use my little shortcut here. So you guys can check your work on this. So 8 over 2 is going to be 4. 4 squared is 16. So that means I have x plus 4 squared. That comes from here. And the 16, I'm going to subtract that 16 off the c value. So negative 2 minus 16 will be negative 18. Completed the square. Now solving, add 18. Take the square root. And subtract 4. Now the square root of 18 can be simplified, right? We can do that little trick where we say what's the largest perfect square that goes into 18, right? I'll do this as part of my side work as well. 18 can be rewritten as 9 times 2. And so that's the square root of 9 and the square root of 2. So 3 square root 2. And so our final answer here would be x equals negative 4 plus and minus 3 square root 2. Okay? You can certainly split the plus minus sign and show those two solutions, but the plus minus sign being there does serve the purpose of showing two solutions. Number three, we have an a value, right? So we're going to have to divide everything by that a value before we can even start completing the square. So I got x squared plus 6x plus, what is that, 2.5? Okay, now I can complete the square. So I'll do a little side work over here. Okay, so it looks like I got x plus 3 in the squared. And then I'm going to subtract the 9 from this. So what is 2.5 minus 9? What's that, negative 6.5, hopefully? And now we go ahead and solve this. So add 6.5. Take the square root. Subtract 3. And we're not going to simplify the square root of 6.5. It's not even a whole number. So that's it. We're done. Okay? So I believe that is it for today. All right, so make sure you go on to Schoology, print out some practice problems. We'll have 5.5 up there. And remember to come seek us out during office hours or send us some questions, whatever you may have, okay? And I will see you guys later.